Hello, this is section 7.1 on system of equations. So for this, we are trying to solve the system by substitution. So notice that this is a parabola and this is a linear equation. So when you have a parabola and a linear equation, you can probably most likely have two solutions. You can also have one solution, or you can have no solution. So those are the three options. So let's see the three cases. Let's see which of the three this one will be. Since they're both equal to y, that means you can set these two equal to each other. So let's set them equal to each other. And now we can set the equation equal to 0 by subtracting 2x and adding 1. That's how we make the equation equal to 0. So we have x squared minus 2x minus 3 equals 0. This is a trinomial that can be factored into x minus 3, x plus 1. And if you solve these two factors, you're going to get x equals 3, x equals negative 1. So those would be the two x coordinates. Now we got to find the y coordinates. So we can choose either of the two. It doesn't matter which one. I'm going to choose the bottom one. So if you substitute 3 in for x, you're going to get y equals 2 times 3 minus 1. And for the second one, you'll get 2 times negative 1 minus 1. And so this is going to be 5, and this will be negative 3. So those are our two solutions, 5 for that one and negative 3 for that one. So those are the 2 points of intersection. What I recommend is that you go to www.desmos.com and you graph these original functions, and you will see that the points of intersection are indeed those 2 points. So you can confirm your answer by graphing them on this website, and you'll see that these 2 are the points of intersection. Similarly, if you type these into Desmos, the top one will look something like this. It's a cubic function. And then the bottom one will look like a parabola. So there could possibly be one solution, or there can be 2 solutions. Most likely, there will have to be 1 or 2 solutions, because no matter the larger x gets, this will eventually intersect the top graph. So let's do our substitution. In this case, I would recommend that we solve for x, since this is the easiest variable to solve for. So we'll add y cubed to both sides. So we get x equals 1 plus y cubed. Then we can substitute this expression into x into the bottom equation. So we have 2 times parentheses 1 plus y cubed equals 9y squared plus 2. Now we distribute and simplify. Notice the 2's are going to cancel. So at this point, we can bring the 9y squared over to the left side to set this equation equal to 0. So now we'll have 2y cubed minus 9y squared equals 0. And we can factor out the y squared from this. That's a common factor. That will leave us with 2y minus 9. Now you have 2 equations, 2 factors to set equal to 0. You have y squared equals 0, and you have 2y minus 9 equals 0. This one's clearly just 0, and this one's going to be y equals 9 over 2. So now we have the 2 y coordinates now. In the previous problem, we had x coordinates. In this problem, we have y coordinates. So now we got to find the x coordinates, and just like we did before, you can choose either one of these equations. I'm going to go with this one, since this one's already isolated. I already isolated x, so this one to me makes the most sense. So let's plug in 0 for y. If you plug in 0 for y, you're going to get x equals 1 plus 0 cubed, which is 1. And if you substitute 9 over 2 for y, you're going to get 1 plus 9 over 2 cubed, which is a very large number. Let's see, what's 9 to the 3rd power? 9 to the 3rd, I believe, is 729. So you're going to have 1 plus 729 over 2 cubed is 8. And I can rewrite 1 as 8 over 8. And that will give us 729 plus 8, which is 737 over 8 is our final coordinate for this one. And for the previous one, it was 1. So those are the 2 points of intersection. Those are the solutions to the system of equations. The next one, this is a circle of radius 5. And this is a linear equation, so you potentially have 2 solutions. Of course, you can also have just 1 solution if it's a tangent, or you can have no solution if it doesn't intersect at all. So those are the 3 cases. Once again, you can type that into desmos.com and graph to see what the graphs will look like. I'm going to do substitution. So substitution, I'm going to solve for, it doesn't matter, I'll solve for y. So if I solve for y, I'm going to get 4y equals negative 3x minus 25. And now I can divide by 4. Or you can just do one large division. It doesn't matter. I'll do one large division. So that will be y equals negative 3x minus 25 over 4. So this is what I'm going to substitute into this top equation. So this is going to get a little messy. X squared plus parentheses negative 3/4 minus 25 over 4 squared equals 25. All right, so what I'm going to do is I'm going to factor out a negative 1/4 to make the math a little easier. So I'm going to factor out a negative 1/4, which will leave us with 3x plus 25 to the second. But because I factored out the negative 1/4 from here, I also have to square that because that's inside of the square. So this should also be squared. So squared. So I'm squaring the negative 1/4 as well as the top, the numerator. So this becomes 1 over 16. So now this becomes x squared plus 1 over 16. If you expand this out, in other words, write it twice and then FOIL, you're going to get 9x squared plus 75 plus 75x plus, I think that's 625. So let's write that out. 9x squared plus 75x plus 75x is 150x plus 25 times 25, which is 625, equals 25. All right, so that is a large, those are some large numbers. So now let's see what we can do in order to solve for x. I would recommend multiplying the entire equation by 16 to get rid of that fraction. So let's multiply by 16, 16, 16. That's going to cancel out that fraction. So we have 16x squared plus 9x squared plus 150x plus 625 equals 25 times 16, which is 400. All right, let's combine like terms. Like terms, so let's bring the 400 over. So now we have 16 plus 9 is 25x squared plus 150x plus 225 equals 0. So now we're at the point where we could actually make these numbers smaller by dividing by 25. So now we have x squared plus 6x plus 9 equals 0. And if we factor, we should get x plus 3, x plus 3. So it looks like there's only going to be one solution. X is equal to negative 3. All right, so let's plug that into the bottom equation. So if we plug that into the bottom equation, so it looks like we have one solution. If you substitute negative 3 into the bottom for x, you're going to get 3 times negative 3 plus 4y equals negative 25. Let's add 9 because that's going to be 9. 4y equals, what is that, 16, negative 16, so y equals negative 4. So that is our final solution. All right, the next problem. Okay, so this is a rational equation or expression that's going to look like that. And this is a linear, so it's going to look like that. So I'm guessing there's going to be 2 points of intersection for this one. All right, let's see if we can do substitution for this one. I'm going to solve for y. You could solve for x as well. It doesn't really matter. But to me, it looks like y is going to be the easiest variable to solve for. So we have y equals 3x plus 5. And let's plug that into the top equation for y. So we have x times 3x plus 5 equals 2. Distribute 3x squared plus 5x equals 2. Subtract the 2 over, and you'll have this trinomial. And let's see if we can factor this. It should be 3x times x. Let's try 2, 1. And that will give us 6, and 1 is 5 if we subtract. So let's do this. We need this to be positive 6 minus 1. So positive 6 minus 1 is 5. So our two solutions are 1/3 if you solve the first factor, and the second factor will give us negative 2. So we do have 2 points of intersection. And now we choose either equation. I'm going to choose the top one. So if I substitute 1/3 in for x, I'm going to get 1/3 y equals 2. Multiply both sides of the equation by the reciprocal. You get y equals 6. Same thing, plug in negative 2 into the top equation again, and you get negative 2y equals 2. Therefore, y equals negative 1. All right, so we are done. The last problem is a 3 variable 3 equation. So each of these equations represents a plane. So think of the wall, the ceiling, and the floor. Those are 3 planes. We're looking for the point of intersection of those 3 planes. So this is a way I recommend that you solve a problem like this. I like to number the equations 1, 2, 3. Then I look for the easiest variable to eliminate. I see that the z's eliminate, so I'm going to choose equation 1 and 2 to begin with. If I add those, I'm going to do the elimination method and get 3x plus y equals 8. I'm going to call that equation number 4. So now I have to go back to the original equations and use the one that I have not used yet. I have not used equation 3, and I have to eliminate the same variable that I eliminated before. So I eliminated the z, so I have to eliminate the 3z now. I'm going to eliminate this one with the top one because they're opposite signs, but I have to multiply this by 3. So let's multiply the top equation by 3 first. And if you do that, you will get 3x plus 6y minus 3z equals negative 3. All right, and then I'm just going to bring equation number 3 over, line it up so that I can do the elimination method again. And now you get cancellation. You get 4x plus 9y equals 3. And I'm going to call that equation number 5. And now I have 2 equations with 2 variables. So I can line these up and do elimination on those 2, 4 and 5. So I'm going to multiply this one by negative 9 so I can eliminate with positive 9. So let's do that now. Negative 9. So the new equation becomes negative 27x, negative 9y equals negative 72. And then I'm going to just bring this equation down underneath it in order to align it so that I can do elimination. And now we got elimination there. So now we have negative 23x equals negative 69. Divide by negative 23. And I believe that should be 3. A negative divided by a negative is a positive. All right, and so almost there. Now we have to go back to equation 4 or 5, it doesn't matter which of the two, and substitute 3 in for x. I'm going to choose equation 4 because it's a little bit more simple. So let's plug in 3 for x and solve for y. So subtract 9, y equals -1. All right, and now you go back to either equation 1, 2, or 3, and you substitute x and y, and that's how you get your z. I'll go with the second equation. It doesn't matter which of the three you choose. So I'll go with the second equation. So you got 2 times x, which is 3, minus y, which is -1, plus z equals 9. So this is going to be 6 plus 1, which is 7. Subtract 7, and you get z equals 2. And so our final answer is going to be in the form of a ordered triple. We're going to write x, which is 3, y, which is -1, and z, which is 2. And that concludes this section.